Alright, in this video we are going to talk about section 1.3, day 2, applications of right triangles. So there's many things that are going to be found using right triangles in trig, but the two main things that we're going to find with right triangles are distances and angles. So distances between two things and the angles between two things. So to find these, we're going to need to have knowledge of our trig functions. So sine, cosine, tangent are going to be the big ones, and then know a little bit about our unit circle as well. So there's two examples we need to look at. The first one is going to be finding an angle between two things. So it says a historic lighthouse is 200 yards from a bike path along the edge of a lake. The walkway to the lighthouse is 400 yards long. Find the acute angle theta between the bike path and the walkway as illustrated in the picture. So we need to look at what we're given. So we see our right triangle here. Here's the question, or the angle in question. So we have the opposite side and we have the hypotenuse. So there's two functions that we can use that deal with the opposite and the hypotenuse. That's going to be sine and cosecant. But generally we're just going to use sine. So we're going to know that sine of theta is going to end up being the opposite 200 over the hypotenuse 400. So if we divide that, we're going to get 1/2. So there's where our knowledge of trig functions needs to come into play. So sine of theta is going to be 1/2. Here's where a unit circle comes into play. We haven't yet talked about inverse trig functions. So we can't do the equivalent of taking the square root of a square. We can't unsine of theta something over on this side. So what we have to think about is where on the unit circle does the sine equal 1/2. So if you think about when sine is going to equal 1/2. Sorry, there's a lot of noise in the hallway. Anyway, so the sine of theta equals 1/2. According to our unit circle, we should know that theta is going to be equal to pi over 6 radians. And this is going to be one of those times where degrees is probably the better way to answer this question. Pi over 6 radians usually isn't going to be the best thing that you're going to want to use to describe an angle like this. So we can say, or 30 degrees. So that's a way where we can find angles. So let's look at one where we need to find a side. So find the length C of the skateboard ramp shown in the figure 1.35. So again, we have a right triangle. We have an angle here. This time they're telling us it's 18.4 degrees. We again have the opposite side and the hypotenuse. So that tells us that we're probably going to want to use sine. Sine of 18.4 degrees is going to be equal to the opposite over the hypotenuse multiplied by c, because that's what we're looking for. Get that out of our denominator. So c is going to be equal to 4 divided by sine of 18.4 degrees. If you go to put this into your calculator, make sure you are in the degrees mode. And if you do that, you're going to find out that it's about 12.7 feet long. So that'll do it for this video. We will see you in the next one.